Okay, my outstanding friends, this goes back quite a ways. They're finally starting to accept electron flood theory. This is a retraction of a paper in Nature magazine, the biggest paper in science. And they're starting to withdraw some of their claims about superconductivity and the makeup of the core of the atom. Physics is in total disarray. And they say here the field has been plagued by a series of astonishing claims, followed by skepticism, social media turmoil, failures to replicate, accusations of misconduct, and eventual retractions. They're trying to put out their support for the Standard Model. The Standard Model does not work. The real model is electron flood theory, dipoles. It's dipole electron flood theory. Originally, I was going to call it by a different name, and I'm going to show you some papers as I started back in 2012, 13, 14. I started, and then I started writing papers, I think around 2015. But I'll show you the advancement of electron flood theory, because it changed a little bit, obviously. And as a matter of fact, this paper came from 2019. The one I'm going to start with, I think, is 2016, somewhere around there. But anyway, and by the way, I have books now on all my research, and they're done not by me. I have nothing to do with them whatsoever. I just said, a fellow approached me, he said, can I use your papers and write little books so that people get an idea of what you're doing? I said, sure. So he's doing it, and it's based on my work, that's all. So, but they at least gives you something you can throw on a coffee table, talk about it. I don't know how advanced they are, to be perfectly honest with you. I just said, you can use my papers, no problem. So that's what's going on there. Now, let's talk about electron flood theory, because that changes everything. And I honestly believe we can get literally free energy with a little bit of work and a little bit of engineering and a little bit of, probably resources to get this done. We need some engineers, we need some people that have equipment and time. So let me show you what I'm proposing. Okay, what am I basing my claims on? I'm basing them right on here. Experimental evidence that shows the muon neutrino, which is the black ball, is this black ball right here. It separates from the electron neutrino, which was a white ball, just like the black one, it was white, and it separates and goes into an electron shower. You can easily see the muon, which was the black ball, stays all by itself, and it reattaches right out here. In the middle, you have an electron shower. What's the big deal about that? All right, here's the big deal. This is Fermilab. They have found these two exact same particles that we have right here. You see them? The red one, and it gets bigger and smaller, and the black one never changes size. It has a glowy edge around it, precisely what they say from Fermilab. And they are attached just like this as a photon. That's a photon of light accelerating. All right, and remember I showed you the electron showers? Well, this, first of all, is a photon of light. And that's what it is. It bounces back at you because it's got a magnetic field surrounding it. And as it goes through the air, it pushes all of the particles in the air in front of it, and they glow. And I can show all this. I have all of this stuff fully visually obvious. This is the particle being pulled ahead of its own magnetic field. It's accelerating because of a venturi. If you understand what a venturi is, you'll understand why it accelerates. And at the venturi entrance, it's so confined that only the white particles, which can get bigger and smaller, can squirt through. This is this. All right. The black particles were attached to the white. Don't forget. This is how they're coming down, zzz, just like that. When they hit that venturi, they separate. The white squishes right down through and squiggles right through the venturi, which is right here, a little tiny slit. And it's rounded, so they have to, all the fields have to come together. And that's really identical to hitting head on at the super colliders. We're just making them forced to sideways, but there's nowhere for them to get back out because all the black particles are here pushing them forward. And the black particles can push the white. This I can also prove. And here's the picture that proves that. You see the black particles right there? They're pushing the white particles ahead of them. And the white particles are putting out what's called a Whistler wave, which is a bounce. The white bounces against other whites. The black just pushes the whites. The black is there as a carrier particle. They've always called them carrier bosons. I don't know why they came away from that. But this is literally almost identical to a nuclear explosion right here. All the white goes out first in these waves. You can hear it go just like that, and then 30 seconds later, the main black comes and knocks the house down. Shown it many times. Okay, so what have I shown you? I have shown you a muon and an electron neutrino. These are neutrinos, and I'm going to show you, the two of them together make a dirac. And I can show you some other things about these neutrinos. Now, when you take this, which I call a dipole electron, because that's all it is, the black is always attached to the white. These are always attached together. They will not come apart unless you do a nuclear explosion. And it is a nuclear explosion. It divides the black from the white, because these are particles that make up a nucleus. This is a proton, all right? And it's made of these particles here. And every one of these is a dipole. Okay, it has a positive and a negative together, so it's locked together. We can see that they have their polarity just like a regular bar magnet. And that's what upspin and downspin is all about. It always follows the polarity of the Earth. That's why they have upspin and downspin, they call it. Anyway, these particles in mass, the first mass that is stable is light, and that's two of these. All right, that is it's a photon. All right, it has two of these, one of these and one of these, and they're back to back, just like that. All right, and as they come through the air, they have a huge, gigantic, I mean, absolutely enormous field, huge, and everything that's in there that it has to pass through gets excited. So you get all the particles in the air start to glow as you come through. That's why you get the haze in the air, because it's pushing against other particles. The fields fight back, you get a little glow. And that's what you look out in the universe. That's what that is too. The universe is continually boiling with these particles interacting out there, just instant, and they're gone, because they're just light particles bouncing into other light particles. They glow for a zillionth of a second, and not very brightly. That's why when you look out the night sky, you can see it's not black. Okay, so don't forget, they're starting to back off of their claims, and they're saying it's a boiling mess of nobody knows anything. Well, they're never going to know anything in quantum, because they don't understand dipole electron flood theory. As soon as they start to look at that, everything makes sense. Okay, I went back to one of my old papers, and I referred to this video that I had put up here. It's called "Light is Dark Energy Until It Hits Matter and Bounces," and it is. It's dark, and it's energy. And this goes back to, well, 7 years ago. I put this up on this other channel I had, which was totally destroyed. I just left it. You know, it's still up there. But like I say, 7 years ago, I finally just abandoned this channel because it was there was a lot of problems, let me put it that way. Now, this was a drawing that I made real quick to show from the sun or from any star, you have all these particles of light spinning. And they spin. They don't flap like waves. They spin like this. And the wide, well, I think it's all in this video way back then, 7 years ago. And I calculated how much the Earth is growing based on the weight of an electron, which is 0.00585 mass units, something like that. Anyway, listen to this. I thought this was pretty cool. I listened to about a minute of it. Here, listen. All right, I'm going to make this extremely short. It's very, very simple. I am saying that light is dark energy, and it's also dark matter, and it's in the vacuum of space as it travels from the sun. It's obviously traveling from the sun, we know that, and it's heading towards the Earth. It hits the Earth, we know that. It's energy when it left, we know that. It's energy when it hits, we know that. It powers solar cells, it grows plants, it does all those things. It has to be energy in the middle, we just don't see it, it's dark. What happens is that from the star or sun, or our sun, it leaves, and they're electrons, they're vortex particles, is the theory. It's a new theory that isn't unproven, but we have a lot of evidence. Anyway, it's spinning particle, and that creates the wave. You see the wave, and it's a particle. And depending upon the frequency, that creates the angular momentum, which creates the mass. So here's the deal. You got particles or spinning electrons, and then no nuclear bits at all, and that's why you don't see them. The entire universe is filled with this energy and this matter, and it is. All right, I want to make one other statement. I'm talking about the electron dipole, the dipole electrons that are coming out of here. They can come in as pairs. They can come in just the black, just the white. They can come in little chunks, 2, 4, 6, 8, 10, 12 little particles together, and all the way up into dust and so forth, into huge particles. So there's a huge range of particles that are coming. But I believe eventually, as they filter through the ether, which is the ether they always talked about in space, they will sort of break down and concuss the big parts away until they pretty much have mostly small parts, and that would be your dipole electrons. So let me just go back, and because I could be confusing. Again, this is 7 years ago. A lot of things changed, and I'm not saying all this is right. I'm sure there's a lot of things that aren't right. Here goes. Particles are spinning electrons, and then no nuclear bits at all, and that's why you don't see them. The entire universe is filled with this energy and this matter, and it is the animating matter of life. It's there to be used to start life and to create energy to do all kinds of things. Now, those particles are spinning electrons. The frequency of the spin times their weight, resting weight, which is supposed to be this, equals the mass. The energy equals the mass, that's all. When it comes down and it smacks into something that has nucleated particles, which means it has electron clouds around a nucleus, it bounces off. When it bounces off, it gives off light. What it doesn't bounce off is absorbs as heat. And it is absorbed as heat in what they call quantum. So it jumps like, and it takes a certain energy level to do that. And we see that in spectroscopy. So that is known. We see light bouncing off of things, that's known. We feel the heat, that's known. So all of this stuff is obviously, and it's all known. Now, then you go down, how much stuff is hitting the Earth? Because now there's weight to this stuff. Yeah, I just showed you that. They say that this is how much it weighs. Now, the Earth is growing like unbelievably. Look at this. The average per square meter, NASA says, is 1,360 watts per square meter, and that's, I believe, per hour. They don't say that, but I'm sure that's what it is. Times a million, which is a million square meters in a square kilometer, times 510 million square kilometers, which is the Earth's, they say, is the surface. And it's even more than that because it's hitting the atmosphere. But anyway, but there is some radiation. Anyway, that would be the watts of the Earth. Now, the watts of the Earth times the electrons in a watt, which weigh this here, is how much the Earth is growing per hour. All right, these are particles that were captured by Rodney Warren. He's doing the experiments, but I believe this is a torus, and somehow the electron activity does what you would think of. I think it might be capacitive inductance, and it's almost doing like an AC thing. I mean, look at it. The white's here, a little white spike coming out here, the white's over a spike here. I think it's doing a flip-flop inside there like AC. Anyway, over here are the... I just want to make a statement. Forget all that. That part about the AC. Like I say, this was a work in progress, so let's keep going. I knew these particles were, I call it atomic vapor. All right, it's like moisture in the air. These particles, and they glob together and turn into raindrops, basically, of matter. You know, I'm just using that as an analogy. All right, here we go. Energy levels. Okay, these are those little particles, and we have them both in red and green, and which blue is the two colors of the lasers we've been using, and which would indicate to me that the structure is consistent, and identical. The color, which indicates the energy, is dependent upon the frequency. Now, this particular shot, and they all do the same thing that we're showing here. There's a vortex up in here. I don't know if you can see that up in this area here, and you can't see it in this shot, but they come out in a vortex spray, a shower. Hold on a second. All right, this is the 3 dimensions of a light propagation wave without hitting a slit. We're just capturing that literally in a mist. You see this? These are all the particles that are in the air. These particles glow because they're being excited by a field that's accelerated and saying, get the hell out of the way. And they say, whoa, whoa, whoa. And it's push to shove, I call it. These are pushing them, these are shoving back. And whenever that happens, whenever you have a snap like that of two things hitting together, you create energy. Energy creates light. Light is absorbed by CMOS, complementary metal oxide silicates. That's what we use to take these pictures, a simple cell phone. And this goes back to 2012. Now, this was when I started publishing stuff. I think it was 2015.
I honestly don't see how this could possibly be denied. This is what I'm saying is the vortex particle. Now look at what I'm saying is happening here. It makes a right-hand spin. You see, just like this. It's coming down and it's hitting right like this. This is exactly what we're doing. Now, it had gone through a Venturi slit way back here. And it came down to here, spinning into this slot. Well, it was spinning into the slot, and we're picking up the radiation down here. Let's put it that way. So it's spinning through the slot, and as it spins through the slot, you can see that it comes off the slot and in, and it gets denser here, and then here it can't penetrate, so it's over the surface, and then poof, it drops back in again here, and you get a dense color here, and then
this is a drill bit. It's screwing its way through here. Just think of it that way. I know I'm making it confusing. But you see all these little interference patterns? Those aren't interference like a flap in here and a flap there. This is a single slit. What's happening is the light is spinning, and every particle says, you stay out there and I'll stay over this way. And they set up these interference patterns. So sometimes it goes this way, sometimes it goes over this way, but it doesn't matter. Once it gets through the slit, it says, you stay over here and I'll stay over on my side. And that's what sets up these interference patterns. They're repulsion patterns.
The pattern, it's very, very apparent. All right, now, I've been talking about these Venturis. Well, this is a Venturi here. There's a round object here and a round pin here. And the light of the laser is being shined through and hitting there. Now, because of the architecture of the slit, it creates what's called a Venturi, which compresses anything that comes in, and the only thing it can do is accelerate. There is no option. So it has to accelerate, and when it does, it creates this chaotic white high-frequency light, which I believe is Cherenkov radiation, which now, as it exits this way and sprays all this white stuff, what it's spraying into is uncompressed space, normal.
Let me just make a mention, because I can see this was a very clear shot of how the reattachment happens. This is attached particles here. The black and white are together here. You saw that in those little 4 blocks, 2 whites and 2 blacks. Right here, they explode and divide, and the black comes away from the white. Primarily, you have almost exclusively black here pushing, pulsating against this white, making it squirt through here. Now, what I want you to look at, though, is right around the edges. You see right around these edges? Hold on, let me turn the lights off. Sometimes it gets a better focus. Sometimes not. All I want you to look at is around these edges. You're going to see all these black particles trying to suck their way back into the white ones. That's all they want to do, is be attached to the white ones. But when those white ones are exploding, there is no reattaching. You see them coming out here? Those are those interference patterns. Those are the blacks and the whites coming back together in little stripy looking things. And the black, just all it wants to do is be attached to the white. Now, that's what electricity is. The two of them, when they're separated, they just don't like that. Boom, they want to come back together. And because the white has a big field, when it pushes through stuff, it forces it. It forces it to get the hell out of the way. That's what energy is. That's what electricity does. It forces things. All right, so anyway, that goes back 7 years ago. And primarily, this was a paper I wrote, I guess back about that same time. Yeah, 2016, that's 7 years ago. And I was going to call this nuclear electron theory, which is the nucleus has electrons. The electrons are not strictly little negative particles. They are black and white particle together. And I started off by being a little contentious, these are considered facts. Light has no mass. That's totally wrong. Light is a fixed speed. Totally wrong. Neutrons are neutral. Well, there's no neutrons, so that's wrong. After that, everything else is just guesswork, so I don't guess. And the rest I show, and I show evidence for everything. And electrons are tiny, approximately 1,800 times smaller than neutrons, or 1,824 times smaller than a neutron. Light and dark forms of energy. Light leaves the sun as an energetic particle, no question whatsoever. Light pushes solar sails, implying weight, which is mass. Yes. Light hits solar cells and displaces electrons, creating electricity flow. And that's only the white. White is the electricity. Light grows biomass, increases weight according to how much the wattage is. The brighter the lights, the better the plants grow. Light is not seen as it transits space to Earth. It just is, it blinks on and off, and that's called a quantum foam. I'll show you those articles from Fermilab. Light still has mass and energy in a vacuum of space as it is in transit. Until it hits anything, it's just there's no energy being transmitted, let's put it that way. It's a potential energy. When it hits something, it turns into what they call kinetic energy, seen energy. Light is actually dark matter. It really is. The light itself has the dark matter attached to it, and dark energy. Both of those things as it travels in the vacuum of space, which is not a vacuum. There is no vacuum. The vacuum of space is completely saturated with particles. Light is vortex electrons. Well, they're spinning particles, yes. And they're seen in these experiments by Rodney Warren. Now, Rodney Warren was the one that I saw his experiment. It blew my mind. And then this is the YouTube that we just watched a second ago. And then I go down to all about the new science, and I give out challenges to everybody and all that business. I started bragging, Okay, this is what I eventually came up with, and somebody did this graphic for me, and I don't remember who it was, and I thank whoever it was, but I didn't do this myself. I just said, here's what I believe. It's either one or the other. It's either all the black goes to the center, and that's what my belief is now, and then the negatives code it, or it's a bunch of black goes to the center, and then you got the really tightly bound electrons, and then you got some more black, and then you got the less heavily, tightly bound, the green, and then you got some more blacks, and then you got the really loosely held, which is the red. Now, my feeling now is that all that black is congealed totally in the center, and you're going to have one little layer right around, a very close layer to the black will have the tightest, and that'll end up coming out blue because it's really being pulled apart. Very, very hard to get those two apart. The next will be the green, and it's not quite so. In other words, just like this. If you get the blue out of there, it's going to be way down in here, and boing, it's going to take off like a rocket ship, and it's going to be really tight, bzzz, coming out of there. But if you're out here in the green range, it's going to come out of there in that range. And if you're out here in the red, it's just going to sort of bounce around out there. And that's what they have found. Exactly like that. So my feeling is it's more this than that, but it could go either way. All right, this is a black hole in space. The Russians created this by injecting charged particles into a vacuum, and they could see that it created a black hole. Basically, that's it. And as far as I'm concerned, that's the dark matter and the dark energy that is particles surround, which is the core of every atomic particle. All right, all those other papers, forget them. This is the one that's as close to reality now. It's from July of 2022. I only got 62 views on it, but it's had some pretty good response because it's pretty obvious. It's what I'm showing is correct. All right, particle physics is not big things. It is inside the nucleus of atoms. So this is inside the nucleus. It's parts of light. Light makes up these nucleuses. So it's dipole electron flood theory, and 1,823 light particles make up a proton. And then protons get bigger and bigger and bigger in that specific quantity. So I go through all this stuff again, and how the electrons come in a ball, and and this is, I don't go forever. These are very short papers. And again, I give credit to Bob Warren. He was basically a hobbyist. I saw what he did, and I knew what he was doing. I don't think anybody else did, because nobody picked up on it. They still don't. So once I saw this in 2013 or so, we were off to the races. I said, Rod, let's do. And I got a hold of Fermilab, and I went to University of Geneva online, and I showed them all our stuff. I showed them all the stuff, and they were pretty impressed. And as a matter of fact, a lot of the things that I showed them, they went ahead and did at CERN. They focused, and they put in CMOS, because that's what we were using to see this. Originally, they said, "No, you can't see that. You're making a mistake." I said, "No, I'm not." I said, "I can see those, and it doesn't damage our CMOS," because they said they would do that, but it destroys the CMOS. They eventually hardened the CMOS somehow, and the CMOS is complementary metal oxide silicates. So they did that from this upgrade. It took 3 years to upgrade. They put in focusing magnets, because I said, if you guys are just hoping that something hits, they're not going to hit head on. They have fields, and the fields just roll over each other. And they said that, yeah, they said we're hitting billions of particles together, and maybe 25 of them hit. Billions. And they maybe get 25. And I said, you're not focusing. So anyway, they focused, and they put in CMOS, because their chunks were so big compared to ours. We started with light, so we don't have any big chunks. What they did was just starting with these. When those hit their receivers, they can hit like that, and it destroys the receiver. It's dead. We never get any bigger than that. It never gets bigger. It hits a lot of them all over the place. But they're meant to receive light particles. They're not meant to receive things like that. You can't use CMOS to see that. You just destroy it. It just smashes the particles to bits, which is fully understood. So anyway, they apparently understood it, and they did something to harden, which probably put a bunch of filters on to take away all the big particles until they just got the little light bits coming through. Why not just start with the light bits? See, this is exactly what I show. This is from Fermilab from 2013. I got a hold of Don Lincoln about this. I said, we found your particles, and it didn't work out well. But it's exactly what I say. The summary, extended particles are the fixed size, the black ones. They may have a fuzzy edge around them, which is the color. The point-like particles are mathematical abstractions with zero size. They have almost no weight whatsoever. I agree with that. But they have an extended field around them, huge, to the effect of the field surrounding them. Now, he also talks about the quantum foam. Remember I said space isn't empty? Well, it isn't. They agree with all of this stuff. Empty space isn't empty. What it is all these particles are hitting and turn into like a foam. The foam on the head of root beer is complicated environment. Bubbles appearing and disappearing instantly. Blip, 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 blip. And this is what happens when the little light particles bang into each other. And the bigger ones are glowier, but eventually they'll drop down to almost all the same size. So the bubbles appearing and disappearing in a dizzying display of change. Empty space experiences similar activity. Subatomic particles zip, winking in and out of existence. These subatomic particles are real and have a measurable impact on our universe. They slow light down, absolutely. So where we think that everything is measured by the speed of light, there's no way to tell what the speed of light is. I can tell you right now, there is no speed of light. Light can go fast, light can go slow. Here it is speeding up. That's pretty obvious. All right, here it is slowing down. And that's also pretty obvious. It's coming in fast. And it's slowing down. The blue is really rocket ship stuff. The green is also pretty fast, but the red is reasonable. You can work with the red. But here's the red coming through. Pulse, 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 pulse. And it's banging everybody else in front of it saying, get out of the way. So they're glowing. This is glowing. This glows a lot because it's the big pusher. These are the guys that got to get swept out of the way. And again, this is what you should be able to get. They want to get down to this, the neutrinos. They have to start with proton-protons collisions, making hadrons and decay of the hadrons and flux energies and creating anti-neutrinos and neutrinos. And then this is where they want to get to, where we started from. The energy of the neutrinos can come up to 100 giga-electron volts, that's billions, to a few trillion electron volts. That's an enormous increase in energy. And anytime you see an increase in glow, it means you have an increase in energy. Right back here, you can't even see it. It's just almost no light at all. Up here, it's just on steroids of glowing. And these are all other light particles that are coming through the air. You would never see them. Remember I told you that you really don't see them until they interact with something violently enough. Normally it's by bouncing off of something. But coming through the air, they're here all the time. You just don't see them. But this is bouncing back so violently that even the fields light up in the air because of the bounce back. This is on steroids energy increase from here. It's exactly, anytime you see an illumination increase, it is an increase in energy. So what does that mean? If we could do this, all right, here's where the laser was. Bup, 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 bup. Here's where the black crushes the white through the venturi. Only the white can get through. Here you have to put in some transition metal type receivers, a different. You want to receive all of these different energy levels. So you would need what they call a perovskites. And then that shoots right down through a photodiode, and it would go through the photodiode into your batteries. And that's all you want is the white. You don't want the black. You don't want the black. All you ever want is the white. And that's all you ever get coming through here. And if you design this correctly, you could point it right into a receiver and just harvest a whole batch of it. And then you run it through your stuff into your motors or whatever you're doing with it, lighting, heating, everything. You do everything with this. It's raw electrons. Just exactly what pumps out of a generator. See, this is also from Fermilab. They see the Dirac neutrinos, and these are very well just black and white. Then the Majornas are sort of variations, and I'll show you what those are right here. These are the black and white particles, which are the photons. And they call these, half of that would be a Dirac, the black and white. Sometimes they'll be all by themselves black and white, but normally we see them in photons. These here are the Majorna neutrinos. They haven't defined themselves yet as a photon or even as a light particle. They're in the midst of turning into this particle. And we see this also with the red. So this is not unknown. Here's the red. The red comes in this way. All right, so it's coming through. Let me turn the light off, make it easier to see. All right, these white and black particles are neutrinos, but they're Majorna, whatever you want to call them. They're not fully into the Dirac mode. And here they are again. These are those particles, but they just haven't formed enough energy to puff up into their photon. And then when it hit here, they just smash to bits. And that's when you get the particles creating the muons and electron neutrinos, or the showers. And that's where you're going to get all your energy. See, this is the green, a little harder to work with. And this is coming through the slit, which is just off kilter just a bit. So the black particles are being shot off this way. There's no black particles here whatsoever. So this is where we want to harvest the energy from. You don't want black. The black, you got to separate the black away from the white. The white is what you put into a battery. When you put that white into a battery, it won't increase its weight. It weighs almost nothing. Exactly like Don Lincoln said at Fermilab. There's no weight. All right, this is exactly what he says. It says the black particles have a fixed size, and they have a weight too. They may have a fuzzy edge around them, which they do. They have that glowy edge. But the point-like particles are mathematically zero size. Well, they're not zero size. There's got to be something there to have a field around it. That's my field. There's no field that has nothing to create the field. However, it is almost nothing. It is something, and that I can prove as well, because I worked with the weights and measures long ago, and I had to have weights certified that they weighed exactly precisely what they were designed to weigh. And I had to take them up to the weights and measures and have them certified. And when I did, I have to leave them there for 24 hours at least so that they became the same exact temperature of everything else that was there. So that they would weigh exactly what they were supposed to at that temperature. And that's what weight's all about. It's about temperature. Now, it was so small, I said to the guy, how could it possibly weigh more when it's a different weight? He says, we really don't know. He said, but there is a tiny, tiny weight difference, and that requires you to leave them here for 24 hours, because I didn't want to leave them. But what could I do? So, and now I understand. And they now say, yes, when a charged battery will weigh more than a discharged battery, but it's so small that they claim it's insignificant. It doesn't make any difference as far as the weight goes, but it's enough that you can drive your car around for 500 miles. Think about how much energy that would take if it was gasoline. Why doesn't it weigh anything? It's these white particles that have the extended field and no mass. All right, here it is right here. A charged battery weighs slightly more than a depleted battery due to its higher initial internal energy state. It has more electrons, basically, and electrons don't weigh hardly anything, but it has a ton of them. By the difference in mass, and therefore weight, is proportional to the difference in energy between the charged and depleted states. Now listen to this statement, though. That's the difference in weight. The difference, however, is immeasurably small due to in the denominator, whatever that means. It is tiny, and it's almost immeasurably small because the electrons literally don't weigh anything. And if you see an atomic bomb blast, well, I'm going to show you one because you won't believe. The white has no mass to it whatsoever, but it has a lot of burn, and that's a lot of energy. And that's what you drive your car on, is the energy, not the mass. Okay, get ready for this. This is Atom Central, Atom Apple II Q House atomic bomb effects. Now, the atomic bomb is going to go off, and what you're going to see is a brilliant glow, and then this just vaporizes. Nothing happens to the house other than it just smokes up. The wires, the poles, everything on this. Now, they have a hardened enclosure here with the cameras facing away from the blast, so it doesn't damage the cameras, and it's hardened, trust me. Now, what you're going to see is this thing just smoke up, and then it's going to go flying when the black wave hits. So here it goes. Let me shut the sound off, and let me turn the speed down just a little bit, so we're down here at half speed. All right, so here we go. Boom. Now, you see it? You see everything just smoking up, smoking up, smoking up, smoking up? Boom, there it goes. That tells you what an atomic bomb does. The first thing to hit when the smoke was just filtering up was all the electrons, the white particles. All right, here comes the white particles. Boom. All right, I just stopped it. Now look at the poles back here. They're just vaporizing. The electrons, they have no weight. Nothing's being pushed. This house is just sitting here. It's just fuzzing up. Look, all this stuff is just smoking up because the electrons are invading other electrons, but they have no mass to them. That's the key. They, for some reason, and I can't tell you why, they have a hell of a field. And that's why all these other particles have fields too. So they're invading those fields. And the result is a glow and a burn. The more the invasion, the higher the glow. The higher the glow, the higher the burn. The higher the burn, the more the smoke. But it's just laying here. It's not moving at all. Look at it. It's just doing nothing. Until all of this stuff is burnt off. Watch. It's virtually all been burnt off. Look, everything's just gone. But nothing's moved. And now comes the black particles. When that hits, boom, it's all over. And watch, it starts to turn around and come back because there's a void back here that is all of the particles have gone away, so something has to fill it. All right, I think I'm going to pretty much leave it right about here. This is the laser. This is the pure, completely raw electricity. That's electricity. This is exactly what you need to make electricity flow. And if you can put it down through a photodiode into the battery, suck a little bit of back to keep the laser going, you should get at least 200 times. They claim that the increase for electron showers is just absolutely phenomenal. As I showed you, hundreds of gigavolts to trillions of gigavolts. So if that's true, and we can push that down in here, you should be able to take something about like this, a handheld device like that, and have enough diodes and you know, enough lasers and enough receivers in here to power just about anything. That'd be a huge amount of electricity come out of here if it's right. And I say it is. I say no other possibility, because as soon as you can create this pure raw white energy, these are electron showers. You see, the black stays by itself. It goes what they call sterile muon. The electron goes into the shower mode. And if you can't see that, I don't know where your eyeballs are. All right? They were attached back here. You saw 2 blacks, 2 whites. No longer. 100% white. That is steroid energy. That is way up there. All right, something you have to understand. There's different types of electrical current. It's the flow of charged particles. Well, charged particles, electron or whatever, electrons, ions, moving through an electrical conductor or space. We're working with space. But you could put those into an electrical conductor as well. You can put it right into a wire, which is going to not necessarily a wire, but we want to put it into a receiver, and then it goes down through a wire, basically. You're just pushing those white particles down into the battery, and it's going to be slamming them. Bam, 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 bam. It's doing all the work for us right there. We do nothing whatsoever other than shine the laser right there and design this correctly. And then it'll just keep slapping that white down in there. We use it for anything we want through our devices. Now, but we're working with electrons basically in the air from light and making them smash down into the solar collector. Think of it that way. There's other things, you can use chemistry and so forth to make electrons flow, electrolytes and plasma and ionized gases and all that stuff. But we're using semiconductors, and we're using light. So the light shines on the semiconductor, and the semiconductor stops things and lets the conduction of the electrons go into the battery. Once they're down in there, they're stuck down there. They can't get back out. That's a gate. It goes through the gate, can't get back out. Boom, 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 boom. And the gate opens, closes, closes, closes. And then you just drive around all you want. This can be held in a handheld device like this. This is, and you could have any. Once you got the juice, you do anything you want with it. After that, you can make AC, DC, any kind of voltage, any kind of frequencies. It's up to you. Once there's all that stuff is done. Everything is done. It's all that stuff is off the shelf stuff now, and even all of the electrolytes and all of the CMOS and all that stuff, that's off the shelf. Lasers, needs a little bit of tuning to do on the receiver. What are we going to use to receive all this stuff? And right now, you could use basically a solar panel. I would think you're going to get some kind of an increase in energy, but I can't be sure of that. But if you had a very good solar collector, perovskite or whatever they call them now, they're these thin film metal receivers. They can pick up all of that X light as energy, and then they filter it down, and you got electricity. All right, I'm going to leave you with this. Once again, they're looking for these gravity waves. You see that black particle and that white particle? Everything is a dipole. This is from CERN or somebody, and here, we found these. Here they are right here. These are the fields. And they're dipoles. Yes, everything is a dipole. Dipole, dipole, dipole. Everything's a dipole. Except the things that don't spin, like the moon. The moon doesn't spin. It doesn't create any dipole activity. When they're spinning, they create dipoles. They create a black and a white. And it's quite obvious. Here's some more. The universe is saturated with these fields. And this is nothing more than another cell phone. This was Dylan Carpenter, who is Rod Warren's nephew, took these pictures with his new cell phone, I don't know, 3-4 years ago. And So light coming to us, we have no idea where we are in the universe or to how far things are away from us. No idea whatsoever. Light has to penetrate this, and it'll slow it down. As I showed you, the blue shows it quite obvious. It'll slow down. You see it coming fast and slowing down, slowing down, slowing. The microwave background, that's infrared microwave background, it's just a very, very, very slow particles. It's just nothing more than light that's continuously bouncing into stuff until it gets to a point where it's just barely moving. That's what the background radiation is. They think it's got something to do with the Big Bang. No, it's just particles that no longer have any energy left to them because they banged in and created all that foam in that quantum foam. And now they're just particles barely moving. We're scrubbing through them. The moon and the sun and all of us are scrubbing through those. That's what creates the corona. It's millions of degrees around the sun, and on the surface it's only 10,000 degrees. It's because we're scrubbing through all these things and being pulled on the arm of the Milky Way and spinning. Our outside atmosphere, the ionosphere, is like 3,000 degrees. Why would it be so hot out there? It's because we're being scrubbed. We're being scrubbed. Our atmosphere is expanding, and it's scrubbing harder and harder. We're getting more and more violent storms, and more. The weather patterns are a disaster, and it's not going to get any better until we diminish the expansion of the gases. That's what's causing this problem, and I don't know if we can stop it now, but who knows?